Hi, in this video I'm going to take you through a couple of concepts that you need to understand before you get to tackle the task that I want you to work on today. Now, last week I spoke about the idea of the number e, and in mathematical circles it really is like the king of numbers. It's a magic number. As the horrendous song that you saw at the start of the video of this podcast, today's blog showed. Now, E was first discovered by a Swiss mathematician called Bernoulli while he was studying compound interest. And I'm going to talk about this a little bit further when we come to deal with E in more detail when we come to the calculus. It was later worked on and used by Napier when he was doing his work on logs, but Leonhard Euler was the man that really did a lot of work with E and brought it into mainstream mathematics and made it such a crucial part of the work that we do today. Because it gets used a lot in calculus as a base, by convention, rather than writing log to the base E, we just write ln x. So rather than writing log to the base e of x, we just write ln x. Now, there's some things that you're going to need to be able to do. You need to be able to solve equations that involve ln x and e. So if we take this first example over here, I need to solve ln of 3 minus 2x brackets is equal to ln of 2x. Well, even though we're talking about natural log and ln, it still obeys the laws of logs. And so I can take this and say, right, this statement, no, go away, I don't want that. This statement is going to come on something like this. I can say the ln of 3 minus x squared is going to be the ln of x squared. Now I have one thing on each side, which means if those two things are to be equal, then that has to be the same as that. So in other words, 3 minus x squared is equal to x squared, in which case x squared is going to equal 3. Actually, 2x squared is going to equal 3. And therefore, x squared is going to be 3 over 2. And x is going to be the square root of 3 over 2. Now note, I only take the positive side of that. I don't take the negative because I don't want to have a negative number. And if you go and work that out on a calculator, come on, where are you, calculator? Oh, it's disappeared. What's up to my calculator? The square root of 3 over 2, let's just clear all that. Square root of 3 over 2 comes out to be 1.22 if I take that to 3 significant figures. Okay, so I've worked out a value for x, a value that will satisfy that equation. If I take that a bit further, I want to express y in terms of x when I've got this statement over here. Well, once again, I'm going to use the laws of logs, so I'm going to rewrite this. I'm going to rewrite this as ln of y plus 1 all squared minus ln of y. So that's losing the third of the laws of logs. And this is going to be the ln of x plus y. And I can tidy the left-hand side up a bit more and make this the ln of y plus 1 all squared minus over y, and that's going to equal the ln of x plus y. That's using the second of the log laws. I'll give myself a bit more space there. Now, once again, like we had in the previous situation, that part must equal that part if this is an equation, if the two sides are to balance. So therefore, I can say y plus 1 squared over y is going to be x plus y. And now it's just a bit of algebra crunching here. I'm going to expand that top bracket. Do I need to expand the top bracket? Yes, because I want to get y by express y in terms of x. Yep, so I'm going to get y squared plus 2y plus 1 is going to equal y times x plus y. That's going to be xy plus y squared. I'm going to need a bit more space there. The y squared is going to go, if I take away y squared from both sides, and I'm going to be left with 2y plus 1 is equal to xy. Let's take away 2 from both sides, and I'm going to get 1 is equal to xy minus 2y. And if I extract a y from that, I'm going to get x minus 2 times y. And then if I rearrange that, I can say y is going to equal 1 over x minus 2. And so I've gone and rearranged that statement and made y the subject of the equation, even though it was quite a complicated looking equation to start off with. Sometimes you might be required to give your answer in exact form. The key to this one, of course, is to make a substitution, to recognize that e to the x would possibly be better expressed as a, in which case this equation is going to be a squared plus 2a minus 15 equals 0. And obviously I can factorize that to being a plus 3, a minus 2 equals 0, in which case a is going to be minus 3 or a is going to equal 2. And if I take that back, I'm going to say e to the x is going to equal minus 3 or e to the x is going to equal 2. And if we take that on and change it from, look at it in terms of a log and find out to solve for x, we can say that log to the base e of minus 3 is going to equal x, or the log of 2 is going to equal x. Now, I can't have this one. I can't have the log of a negative number. If you remember about the log graph is doing that. I never get a value that is negative. So this is not possible. And so I'm going to get that x is equal to ln 2. So that's enough in terms of solving for equations involving x. We also need to look at log inequalities. Now, an inequality doesn't give us just a single or finite number of values for x. It gives us a range of values for x. So we need to keep that in mind when we're solving log inequalities. It's also useful when you're solving log inequalities to think graphically as well as algebraically, because sometimes there's some little catches that can catch us out if we're not careful. So if we take something simple as this, 6 to the x must be less than or equal to 1.7. So I can't go and just in the top of my head figure out what the power is going to be. So what I need to do is I need to take the log of both sides. So I can go the log of 6 to the x is less than the log of 1.7. And if I use my laws of logs, I know that this is going to be x log 6 is less than the log of 1.7. And so x is going to be, oh wait, hang on, I'm working with an inequality. And if I divide with an inequality, I've got to be careful whether I'm dividing by a positive or negative number. Let's just be careful and check. What is the log of 6? Log of 6 is a positive number, so that's fine. I can go and divide both sides, 1.7. I can divide that by the log of 6, and I'm not going to be breaking any mathematical laws. If I go and look at that, I'm going to have the log of 1.7, and close the brackets, divided by the log of 6, and I come up with a number of 0.296. So x has to be less than 0.296. And that's to 3 significant figures. I didn't have to use log 10. I could have used the natural log, so I could have said over here I could have taken this down and said ln of 6 to the x is less than ln of 1.7. That's x. Ln of 6 is less than the ln of 1.7. If I go and check what the natural log of 6 is, it comes out as being a positive number, so I'm fine. If I divide both sides by that, x is going to be less than the ln of 1.7 divided by the ln of 6. And if I do that calculation, the natural log of 1.7 divided by the natural log of 6, once again I come up with the same number, 0.296. So x must be less than 0.296. And that's 3 significant figures. All right, so that looks all good. Now, let's take a look at this situation. It looks very much like the previous one, Mr. King, you say. And yes, it does look very much like the previous one. So I'm going to take the natural log of 0.6 to the x. It must be less than the natural log of 0.7. Now, if we go and check on the calculator, what is the natural log of 0.6? The natural log of 0.6 is a negative number. So even though I might rearrange this to being x ln of 0.6 is less than the ln of 0.7, because this thing over here is a negative quantity, when I divide both sides by it, I must change the sign of the inequality, and I'm going to get this statement over here. And if I calculate that, I get the ln of 0.7. Incidentally, that is also a negative number. The ln of anything less than 1 is going to be a negative number, divided by the ln of 0.6. And if I close that, and I get 0.698. So x must be greater than 0.698. And there's my solution. If I come to an equation like this, or an inequality like this rather than play around with this 4 that's sitting over here on the left hand side, I'm going to start off by rearranging that and just get this base 3 to the 2x minus 1 by itself and say that's going to be greater than 5 over 4. I can do that because 4 is a positive number. I can divide and it doesn't change the inequality. Now if I go and take the natural log of both sides, notice I'm using natural log a lot now. Ln of 5 over 4. That's all good. Again, using my laws of indices, I'm going to bring this down to the front. And I've got ln 3 is greater than or equal to ln of 5 over 4. And when I multiply this out, I'm going to get 2x ln 3 minus ln 3 greater than or equal to ln of 5 over 4. Now it's just a case of rearranging what we've got there. I'm going to take this ln 3 across the other side, so I'm going to get 2x ln 3 is going to be greater than or equal to ln of 5 over 4 plus ln of 3. Ooh, first law of logs, I can use it there. What about the ln of 3? I want to get rid of it on the left hand side. The ln of 3, is that a positive or negative number? We just check. The ln of 3 is a positive number, so I can divide both sides by 2 ln 3. And so I'm going to have here the ln of 5 over 4 times 3. Remember, that's the first law of indices, divided by 2 ln 3. And if I rearrange that, I'm going to get that x is greater than or equal to the ln of 15 over 4 divided by the ln of 9. And there is my answer in exact form, if they've asked it for you in exact form, or yes, we could change it to a decimal if they'd asked it for a decimal. But sometimes they ask it for exact, so you just got to make sure that you get to the right form. Right, I hope this makes sense to you. Look at this again. If there are any questions, you can always contact me by email. Now you need to go and work on the exercise that I have listed in on the class page. Good luck. Go well.